Okay, today we are going to talk about the coordinate proof of right triangles. When you're dealing with right triangles, we're going to have to prove that they are right triangles. And we're going to be on a coordinate plane. So let's make sure, first of all, that I'm going to use 3 different colored highlighters today. I'm going to have a pencil and I'm going to have a pen. It's always good to have multiple colors, because when you work in multiple colors, it allows you to remember things quicker. So let's get started. It says, in order to prove if a triangle is right, you will need to determine if there is a right angle. Okay, a right angle is made when 2 slopes, because we have line segments, 2 slopes, are perpendicular. If you don't remember what perpendicular means, there were 2 characteristics of perpendicular lines. The first one is that the slopes had to be opposite. The second one is that they had to be reciprocal. And opposite, one was positive and one was negative. Reciprocal means that the fraction was flipped. Okay, therefore, what we need to know is the slope formula. So the slope formula starts out with the letter m, and it's equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and remember, these are not exponents right here. This is just saying I have one point, one vertex that is x1, y1, and then I have another point or another vertex that is x2, y2. If we had a third point, we would call it x3, y3. Okay, y sub 2 minus y sub 1. So let's get started on our first example. It says, prove the triangle with vertices a, -4, 2, b, -1, 0, and c, -3, -3, is a right triangle. So, draw my sides in. And if I were you, I'd get a straight edge. ID card, side of an iPhone, something that would help. And then we're going to figure it out. So the way we figure it out, it says a right angle is made when 2 slopes are perpendicular. So we need to figure out the slopes. So let's start with AB. And I'm going to take AB and I'm going to put a little pink highlighter mark around it. And we're just going to take the points, the vertices A and B, and figure out the slope. So 2, y2 minus y1 would be 2 minus 0. Over, and then if I started with 2 and finished with 0, I have to start with -4. So -4 minus -1. And then we're going to simplify that. M is equal to 2 minus 0 is 2. -4 minus a -1. I'm going to pick up my pen here, and I'm going to go 2 negative signs. 2 negatives make a positive. So -4 plus 1 would be -3. So my first slope for AB is 2 over -3. Now 2 over -3 can also be written as as -2 over +3. And I'm going to show you that in a minute. But as long as you have one negative sign, you are in the fraction. It doesn't matter where it goes. It can go in the numerator, it can go in the denominator, or it can go out in front of the fraction. The next one that we're going to do is BC. And I'm going to put a blue mark around BC. Again, for future. Okay, so let's figure out the slope of BC. And the slope of BC is, we're starting with 0, and we're going to -3. So 0 minus a -3 over -1 minus a -3. And again, I'm going to take out my pen because I have 2 negatives here. I'm going to make that a positive. I have 2 negatives here. I'm going to make that a positive. So my slope, when I simplify it, will be 0 plus 3, which is 3, and then -1 plus 3, which will be 2. So I take this slope for BC and I put it over here and I go 3 over 2. Now, as soon as I get two slopes, because all it says is a right angle is made when you have two slopes that are perpendicular, I want to see if they're perpendicular. Perpendicular said they're opposite, one positive, one negative. Well, I have a negative slope here and I have a positive slope here, so it satisfies that characteristic. And the reciprocal, which means a fraction flipped, 2/3 and 3 over 2. So therefore, this right here is a right angle. We just proved that this is a right triangle because these slopes are perpendicular. And that's the symbol for perpendicular, an upside down capital T. Another way that you could find the slopes is we have AB right here, right? So we have this line segment. You could always do your slope triangle. Slope triangle is you start at A and you go to B, boom and boom. And we have going over in a positive 3. And then we go down, I'm going to write it over here, a negative 2. So our rise was negative 2. Our run is 3. Negative 2 over 3 or 2 over negative 3. Like I said, it doesn't really matter where the negative sign is in slopes, as long as it's either in the numerator or the denominator. As long as you only have one, it doesn't matter. For our BC, we'll go right here, use the blue highlighter, and look at this. Our rise was a positive 3. Put it there. And our run, from moving from left to right, would be a positive 2. So rise 3 over run 2. Okay, we could find the slope of AC, but you don't need to because we've already proved that it is a right triangle. So AC down here, would be we run 1 and down 1, 2, 3, 4, 5. We get a negative 5. So our slope for AC would have been negative 5 over 1. Okay, and if we did the math, you would find that out as well. AC M is equal to 2 minus a negative 3 over negative 4 minus a negative 3. When we simplify that, 2, this turns into a plus, this turns into a plus. 2 plus 3 is 5 over negative 4 plus 3 would be negative 1. Again, 5 over negative 1, negative 5 over positive 1, same difference. Okay, let's look at our second example. And I'm going to start this example for you, and I'm going to let you finish it. We have the second and we have the third example. So if you need to, go back and pause the computer for the first example, copy it down, and then use that to help you with your second and third example. I'm going to help you right now. I'm going to plot the points. So we have proved the triangle with vertices D of 0, 3, D, E of positive 3, negative 2, E, and then F of negative 2, negative 5, F is a right triangle. So again, we're going to connect the dots. That is what your triangle should look like. This is a D up here. Okay, this is the triangle here. So what I want you to do is I want you to find the slopes of DE, of EF, and of FD. And once you find the slopes of these three, determine if you have one pair or two slopes that are perpendicular. And I also want you to do it for the third example down here. Okay, good luck, and we'll go over this in class.